All right. So we left off on AX4, and we had this tetrahedral.
You put SP3 on this.
Oh, forgot that. Thank you. All right, so I think I have it filled out where we left off on the part 1, and we had this tetrahedral shape. So we're going to go to the next part now, but this is where we left off with 109.5 degrees is what it was. So now we're going to go to if we lost one of these bonds. So if we lost one of these bonds, we'd still have the central atom A, and we'd still have 3 X's, but we're going to go to AX3E. What does the E stand for? E is for electrons. And so I'm going to replace one of these bonds with electrons. Okay, so we've got some spare electrons here. And so we're looking at now still a tetrahedral shape overall, but we want to look at what is the molecular shape here, because molecular shape did not involve these top electrons. So what is that molecular shape of just this central atom and these 3 green ones? What would we call that? A what?
Trigonal plane.
A trigonal pyramidal is what we're going to call it, because it is like a pyramidal. But we're going to put that word trigonal in there. So a trigonal pyramidal. Trigonal pyramidal. We could also call that a tripodal. It's not going to fit in there. I'm not going to write that. But that's a trigonal pyramidal or a tripodal. Prefix tri meaning 3. And I've got 3 atoms coming off this central atom. All right, so when you do this, you've got electrons here. And you've got electrons floating around these, right? And when you put a negative against a negative, what are those 2 charges going to do to each other? Attract or repel? They're going to repel because they're the same charge, right? Think magnets. All right? And so because of that, these electrons are going to push against these, and it's going to bend these a little bit inward. And so our angle here is actually going to be less than 109.5. We're at 0.5. So where it was 109.5 when it was all equal, now it's bending these a little bit, so we know it's less than 109.5 between all these, where these angles are. All right? So would we call, you think this is polar, or do you think it's non-polar? Remember, polar means that it's shared unequally. Non-polar is everything is equal. It's polar. It's polar. So an example would be in H3. NH3 would be a good example because you've got an N, you have 3 H's, and you have some extra electrons off to the side. Okay. All right, so what do you think the next one we're going to go to is? AX2E. AX2E. Again, the E is for electrons. And again, I don't know why my board is so crazy. AX2E. So I'm going to take off another bond. Add some electrons. So you have something that looks like this. You've got 2 of the one central atom and two of the other atoms here. And you've got electrons off to two other sides. Okay? So, what shape? Overall, it's a tetrahedral shape because you've got two electrons. You still have four things coming out, right? Okay, but looking at just the shape of the atoms, just the molecular geometry, you've got 1, 2, 3. So what kind of shape would that be?
A bigger shape.
A V shape, or it would be bent. V shape or bent. Yes.
What are we putting for the 3D pictures here and here?
Oh, I'll go back.
Okay.
I'll go back to those because I can't draw that. I don't have enough room to draw that on here. So I'll go back to the shape. Oh yeah, because these really should be in this column, but I can't fit them in there. Okay. All right. So our angle is still going to be. Anybody? Any guesses? Less than 109.5. It's still going to be less than 109.5. So am I going to have a polar or a non-polar? I'm going to have a polar. So it's not going to be equal. So an example of this one would be H2O. That would be an example of this one. All right, so now I'm going to go to just an A, X, E. We went down from 4 X's to 3 X's to 2 X's. Now I'm just going to go to 1 X. With 3 sets of electrons. If you want to, you can also add a 2 there for 2 electrons, and here I've got 3 sets of electrons. Leave that. So here is what that's going to look like. I've got a central atom and one atom extending off to the side. All right, so we know that's a tetrahedral still because overall, but looking at the molecular geometry of just the atoms, what shape is that? Linear, because it's a line. That is linear. What angle? No angle, because I have to have at least how many atoms to have a bond angle? I have to have at least 3 atoms to have a bond angle. So there is no bond angle here because I only have 2 atoms. And it's already filled in on my, is it filled in for you over here?
Yes.
Okay, so if A is equal to X, meaning if you have both the same atoms, it's nonpolar. But if they're 2 different atoms, like here, it's going to end up being polar. The electrons will be shared unequally. If any kind of the diatomic molecules like Cl2, F2, Br2, those will end up being the nonpolar. The polar might be something like hydrochloric acid, HCl. Where you've got some extra electrons and you've got 2 atoms. All right, so let's look at the shapes of these. Let's look at the shapes. There we go. All right. So if you look at we did AX4, right? So if you look at AX3E, you're gonna be looking, it's all the same shape, you're just replacing with electrons where you had X's. So you're gonna have an A, and you have an X down here. You have electrons here. We're gonna do those wedges again to kind of show that it's coming at us. Because it's not really a cross shape, and if we do those straight lines, it's gonna be kind of a cross shape. This is gonna be an X, and this is gonna be X. So you have your AX3 with your 2 electrons. So for your AX2, all you're gonna do is, did everybody get this? Yes. All right. So for your AX2E, you're just gonna put 2 dots down here at the bottom. Alright, and then we're going to erase that and make AXE3, and we can do, just replace another X with 2 dots. Alright, on to the next page. Oh. Alright, so we're going to get a little more complicated this time. So we're going to go with AX5. We're going to skip to AX5. So I need Okay. So here we have an AX5. One in the middle, one central atom, 5 atoms around it. You have 2 coming off the sides here, or you could turn it this way, top and bottom, and the other 3 are kind of in a triangle. So we'll go back and draw these after we get done with the chart, but let's do the chart first. What is the overall geometry you think? What would you call this?
Definitely a shape.
If you could divide it into 2 shapes, think top and bottom.
Almost like a diamond, maybe.
What if I could like split it right here in a plane, and so I'd have just this top and this bottom? 2 pyramids. And what is the prefix for 2? Di, or what's the other one for 2? Di or bi, okay? So it's going to be bipyramidal because it is like 2 pyramids put together. So it's a bipyramidal. And what kind of shape is a pyramid? Like what kind of shapes put together is it? 3D, obviously. A what? A triangle. So we're going to reflect that tri in here. We're going to say it is a trigonal bipyramidal. A trigonal, that's hard to read. I'm going to spell bipyramidal for you, okay? B-I-P-Y-R-A-M-I-D-A-L. Bipyramidal. Trigonal bipyramidal. So 2 pyramids stuck together. And so the molecular geometry is the same as this because we have all 5 attachments here. So we're still going to call this the same thing, a trigonal bipyramidal. Now our bond angles are fixing to get a little complicated because we've got lots of different ones. What would the bond angle be with these 2? If I go down and over. That's a 90 degree. And I have a bunch of 90 degrees because this is 90, this is 90, this is 90. What about the bond angle of, say, these 3? These 2 that I'm touching and the one in the middle. That's a 180. So it also has a 180 degree bond angle. Now, what about the bond angle of, say, these 3 that are, these 2 and this bottom one here, and it goes like this? 120, because it's 3 different parts. So you have a 90 and a 180 and a, if it'll fit, well, no. A 90, a 180, and a 120, all in this trigonal bipyramidal. 90 degrees, 180 degrees, 120 degrees. Our hybridization, we are actually getting into some D elements here. So we're going to say sp3d. sp3d. Now, do you think this is polar or non-polar? This is non-polar. That is non-polar. Will you go get the door, please?
Boys.
So we're going to start with the second one on this 5, and we're going to do, we did AX5, so what do you think's next? AX, go down.
4.
4. AX4, and we're gonna replace one of these items with an electron, or with a pair of electrons. So I'm gonna take this off. Actually, let's take this one off, one of these. I'm gonna put this electron on. Alright, so this is what it looks like. Okay. You just have these are this little piece represents electrons. And so now we have to look at the shape. We'll come back and draw these 3D pictures later. It's still overall shape. The electron geometry is still the trigonal bipyramidal, because you got a pyramid on top coming to a point here, and you got a pyramid on bottom coming to a point here. Okay, so that's still the same. But if we look at the molecular geometry, that's just the atoms. That means we don't look at the electrons. We just look at these right here. So what does that remind you of? Back and forth, back and forth. A seesaw. So that is the shape that we're going to call this. We're going to call this a seesaw. And that, of course, wrote it all crooked. See if I can move. Nope. A seesaw. This molecular geometry of this is a seesaw. You can also call it, it's got 4 atoms here, so sticking off a central atom. You could also call it an irregular tetrahedron. Remember, tetra means 4. We're going to go with the seesaw shape. And so let's look at our angles. We've got electrons here. What are the electrons going to do with the electrons around these? Attract or repel them? If I've got electrons here, what do electrons do to other electrons? Negative against negative. They're going to repel. And so there's electrons around these as well. And so they repel each other. So when we're looking at our bond angles, first, do we have bond angles? Yes, because there's more than 2 atoms. You have bond angles. But these electrons here are going to cause all these angles to come in just a little bit, because it's repelling them. Not much, but just a little bit. And so our bond angles, instead of 90, 120, and 180, we're going to be just slightly less than all those. So you're going to have one that's a little bit less than 90. That's a less than sign. You got, oh, they put the degree sign way down there. Let's see, a little less than 120. And a little less than 180. That says less than 90, less than 120, less than 180. We had our hybridization in the other day. So do you think that this is going to be polar, or is it going to be non-polar? It's going to be polar. It's going to be polar, because it's not the same all the way around like the other one was, so it's going to be polar. An example of that is going to be SF4. Now, I'm not going to make you memorize these examples. I'm just trying to give you examples to kind of see what you could plug in there. All right, so let's go next to AX3. So how many E's would we have? 2. That should be AX3E2. I have no idea why my board is not writing in those gaps. That should be AX3E2. All right, so let's get another set of electrons here. So here's what we have. So your molecular geometry, your overall geometry is still this trigonal bipyramidal. You've not changed that, you just put electrons where your bonds were. But let's look at our molecular geometry, the shape with just the atoms. What does that remind you? Just the atoms, just the white and the beige here. What shape would you call that? Try to ignore the electrons. What shape would you call that?
It's like a T.
It's a T shape. Looks like the letter T, so it is T shaped. It is T shaped. Now, let's pretend these electrons weren't here for a second. What bond angle would this be here? Straight across. 180, because it's a straight line. What bond angle would it be here or here?
90.
90. But because these electrons are here, are these going to reach their full potential at 180 and 90? No, it's going to repel them a little bit, right? So less than 90 and less than 180. Just a little bit less than 90 and a little bit less than 180. So you think this is going to be polar or non-polar? Polar. Polar. An example here would be, what does it give me? ClF3. All right, so let's go to the next one. We're going to have AX2E3. 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 I know I'm repeating that a lot, but I know it's hard to read on the board, so that's why I'm repeating it so much. All right. What's our shape here? Our molecular, our overall shape is still the same, the trigonal bipyramidal. But what is our molecular shape of just the atoms? What'd you say? Linear. It's a straight line. Have two white and one beige. Are you sure? That is a linear shape. Linear, for some reason it's not writing. Linear, linear. Linear. So what is my bond angle with linear? 180. And this one is actually going to be 180 because it's all equally spaced. These electrons are all equally spaced. So you're going to actually have 180 degrees here. So would you say that this is polar or is it non-polar? That one is non-polar. An example of this, they did not list one. Oh, no, they did. They did. We have I3 would be an example. Or IF2 would be an example. All right, let's say that we took the last one off. Let me move this up. And we go to AXE4. So we take one of these off. And we put another electron. What's my molecular shape here? Of just the atoms? Whoop. Do what? The overall shape of the big column is still the trigonal bipyramidal. But what is just the atoms here? Whoop. The beige and the white. What shape is that? A linear. It's in a line. I heard it over here too. Somebody. So it is linear. Does it have a bond angle? No, because there's only two atoms. So there is no bond angle. Polar or non-polar? It's going to be polar. It's going to be polar. All right, now let's do the last page. Do what? Oh, the 3D pictures. Yeah, we can do those real quick. Actually, we're gonna skip those for time's sake. We're gonna skip those because I'm not gonna test you on those. I want you to be able to pick out polar, non-polar, bond angles. So, there we go. I'm gonna go ahead and lift this up and take my mask off too. All right, so now we're going to go to AX6. Is that already filled in on your chart for you as well? Okay, so let me get the appropriate pieces here. So we're going to have A, which is going to be one central atom with 6 coming off of it. Okay. So in that here's our AX6, and that last one we had 3 coming out the side right here, right? And so it made that pyramid shape with 3 sides. This one, how many sides would it have if you were to put a side for each part coming up? I don't know if that makes sense or not. 4 on top, and how many on bottom? 1, 2, 3, 4. So if it comes up, I'll attempt to draw what I'm talking about. Does that make sense? Do y'all get what I'm trying to say? Like 1, 2, 3, and 4, and then on the bottom 1, 2, 3, 4. So how many sides would that be total?
8.
That would be 8. Okay, so maybe we can just go on with this for time's sake. So since that's going to be 8, we would call that an octahedral. octahedral, octahedral, or it can be an octahedron. Y'all might can all fit it on one line here. I'm not able to. Octahedron, or what does it still remind you of shape-wise? Coming from the middle up to the top. A pyramid. But instead of a trigonal pyramid, tetragonal pyramidal. Tetragonal bipyramidal. So it can be any of those. Octahedral, octahedron, or a tetragonal bipyramidal, because the pyramid would have 4 sides. Does that make sense? Like, do the names make, do you see where the names come from? Okay. So on the first one with the AX6, since we're not touching anything, we're leaving it all the same, our molecular shape is still the octahedral. Now it can also be any of these, either of these other two as well. So let's look at our bond angles. What bond angles do you see? Without me pointing them out, what bond angles? 180, because you see a bunch of straight lines, right? You see 90s. That's it. So you've got 90 degrees and you've got 180 degrees. Your hybridization, you're getting into sp3, d2. Now, would you say that this is polar or non-polar? Non-polar, because it's equal all the way around. It's equal. So that's going to be non-polar. An example would be SF6. All right, so now we're going to go to AX5E and replace one of these with an electron, or with a pair of electrons, or an orbital. This really represents an orbital that electrons will be in. So, if we look, our overall shape is still octahedral, or electron geometry, but our molecular shape now changes. Our molecular shape, we're going to call that, does it still look like a pyramid? Mm-hmm. Yes, but the bottom of the pyramid is a, what shape would that be? 4-sided square. So we're going to call that a square pyramidal. Polar or non-polar? Polar, because these electrons now, they're just electrons. They're going to push this down. So that would be polar. And what bond angles are we looking at? Less than 90 and less than 180. Because it's right there at 90 and 180, but then these electrons come and they repel the other electrons, and so it pushes them just a little bit. Okay? An example might be BRF5. All right, so we're going to go to the next one. We're going to go to AX4E2. AX4E2. All right, so I took off the opposite side, the atom that was attached on the opposite side. What shape do you see? See a square. I'm going to go ahead and go write square in there. Now, but is it like a cube square? No, it's a flat square, right? Could we say, here's a math term for you, could we say it's on one plane? Y'all use that terminology in math? The plane, it's on one plane. So we're gonna call it a square planar. Square planar. Because it's not like a cube, it's not 3D, it's just 2D, where we see the square. What are my angles here? And 90. You got 90 degrees right here, and then you got straight across 180. So 90 degrees and 180 degrees. Would you say that this is polar or non-polar? Discrepancy. This one is non-polar. Because these push equally against, and so it evens it out. So this one's going to be non-polar. It's going to be evened out. An example. Here's a rare example where you might see a noble gas bonded with something. That's the example they give. All right, so let's go to AX3E3. Let me take off a bond here and put an electron orbital. What shape do you see? Amongst the atoms, we've already got the overall electron geometry. What is the molecular shape of just the atoms? The silver and the white here. That's a T shape. That's a T shape. And what bond angles do you think we have? Less than 90 and less than 180, because we stuck this orbital here with electrons. It's going to repel that a little bit. You see the 180 here and the 90, but if it repels it, it's going to be slightly less than 90 and slightly less than 180. So are we looking at polar or non-polar? Polar. Looking at polar. All right, let me replace another one. We got AX2, E4. What's my shape of just my atoms? Linear. So what is my bond angle? 180. And it's going to be right at 180, no less than, because these are all equaled out here as far as how they're spread out. So it's going to be 180. Polar or non-polar?
Non-polar.
Non-polar. Non-polar. All right, so I'm going to take off one more. We're going to do the AXE5. All right, so I still have the octahedron overall shape. What is my shape of just these two atoms, my molecular geometry shape? Linear. It's a line. Linear. Do I have a bond angle? No, because there's only two atoms. I gotta have three. All right, so there's no bond angle. Polar or non-polar? It's gonna be polar. All right. Stop the video. If you're virtual, just fill that out on the document that I post, and you can turn that in.